Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi there, Herman and Corn. So I'd love to chat today about another fairly niche subject, but I think it's one that we should have a good episode about at one point, and that is what happens, or the type of file systems you can create by putting multiple computer disks together. So in my computer, my workstation, as I call it, that is being a very, very interesting and educational experience, I would say, in learning a lot about the inner workings of computers and hardware. I think I'm running like 5 disks in this computer, and it's using Btrfs. That was actually one of the first times that AI totally amazed me in its capabilities for doing things more than just having a conversation through a chatbot. It actually guided me through the installation of Ubuntu with Btrfs on a 5-disk array, which is pretty complicated stuff. But there's a few players in this world of putting together multiple disks. We have Btrfs, we have ZFS, which I think is kind of the very heavyweight operator here. What really impresses me about Btrfs and why I went out of my way to find a way to install Ubuntu on a backbone that would support this is that ability that we see in stuff like NASs to support the failure of one or more disks, and we'll talk about RAID in another episode. But the snapshotting is what's absolutely incredible. I've been into backup, or I wouldn't say into backup is probably the wrong way to put it, but using backup solutions for a while now. Very important. The more you tinker, the more at risk you are of breaking things, and the more useful it becomes to have an easy way to recover your system. And these systems that create virtual disks built upon multiple physical disks are, to my mind, just about the ultimate snapshotting and backup tool, because you're not restoring an application if that breaks. If your whole system breaks, or you can just roll back the whole system. And what's really amazing to me is that the data involved in creating these recovery points, these snapshotting points, is actually fairly modest. So you can have an incredibly resilient system, and that takes a lot of the risk out of tinkering with computers, and especially using AI agents on the local computer. I really think Btrfs is one of the most remarkable and useful things I've seen in Linux in 20 years of using it. It's brilliant, and it's not even like a backup software. It's the system itself has that, and if we're going to kind of get really into it, we probably should call it a snapshot and not a backup, as they're not quite the same thing. But for the just general recovery use case, it's an incredibly powerful utility. So I'd love to know a little bit more about these systems and how they do this kind of almost miraculous work under the hood of taking they can even use different types of storage. You can have I have an NVMe and an SSD, which is not actually a very smart way to do it, because you're going to be losing the speed of NVMe, but they can do it. And I think you can even put together different manufacturers, different types of storage, and they'll just make it look like one big disk, and then do all this crazy stuff under the hood of parity, organizing bits. And it's really actually kind of almost insane technology to think that you can just really get for free. If you go out and buy a couple of disks and install something like Linux on it, you can get all this virtualized file systems. It'll just kind of do all that stuff. But I've no doubt that the apparent simplicity is deceiving, that there's some brilliant mathematics and computation making all this possible. So Herman and Corn would love to hear your erudite explanations on these systems. Btrfs, ZFS, supercomputers might all be related topics we've touched upon before. How do these work? How does the snapshotting work so space efficiently? And which of these, what's the difference between ZFS XFS, Btrfs in simple terms.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I am sitting here in our living room in Jerusalem, looking at a very impressive and slightly intimidating tower of computer hardware that belongs to our housemate, Daniel.
Herman Poppleberry at your service. And yeah, Daniel has really gone down the rabbit hole with this one. He sent us a prompt about file systems that span multiple disks, specifically Btrfs, ZFS, and XFS. He's actually running a 5-disk array on his workstation right now using Btrfs, which is pretty bold for a home setup, but also incredibly cool.
It is fascinating because most people just think of a hard drive as a box where you put files, and the file system is just the way those files are organized. But when you start talking about spanning multiple disks and things like space-efficient snapshotting, you are really talking about the fundamental architecture of how data exists on physical matter. It is much more complex than just a digital filing cabinet.
It really is. And Daniel's experience with using an artificial intelligence agent to help him install Ubuntu with Btrfs on a 5-disk array is a great example of what is possible in 2026 on a home workstation. These technologies used to be reserved for high-end enterprise servers in climate-controlled basements. Now you can set it up on your workstation with a bit of help to navigate the subvolume layouts.
So, let us dive into the meat of this. When we talk about a file system spanning multiple disks, we are essentially moving away from the traditional model where one disk equals one partition equals one file system. We are talking about pooling resources. Herman, how do these systems actually manage to treat 5 different physical objects as one cohesive space?
That is the magic of storage pooling. Traditionally, you had the file system on top and a separate layer called RAID underneath it. The file system was blind to the disks, it just saw one big virtual drive. But with ZFS and Btrfs, the file system and the volume manager are the same entity. They are disk aware.
And that awareness is key, right? Because if the file system knows where every single block of data is on every single physical disk, it can do things that a traditional system just cannot.
Exactly. It can optimize for speed, ensure data integrity by comparing copies on different disks, and handle those snapshots Daniel was so impressed by.
Let us talk about those snapshots, because that seems to be the feature that really blew Daniel's mind. He mentioned that the space involved in creating these recovery points is incredibly modest. To a casual user, that sounds like magic. If I have a 1 terabyte drive and I take a snapshot, shouldn't that take up another 1 terabyte of space? How does it stay so small?
This is where we get into copy on write, or COW. Most traditional file systems use an in-place update system. If you change a word in a document, the computer finds the exact spot on the disk, erases it, and writes the new word over it.
Right. It is like using an eraser on a piece of paper and writing in the same spot.
Exactly, but Btrfs and ZFS never overwrite data. When you change that word, the file system writes the entire new version of that block to a completely new, empty spot on the disk. Then it just updates its map, its pointers, to say, hey, the current version of this file is now at the new address.
Okay, so the old data is still there, just sitting on the disk, but the file system is essentially ignoring it for the current version of the file.
Precisely. And that is why a snapshot is so efficient. When you take a snapshot, the file system basically just freezes that map of pointers. Since nothing is ever overwritten, that old data stays exactly where it was. The snapshot doesn't copy the data, it just protects those old blocks from being recycled.
So, the only extra space a snapshot takes up is the space for the new data you write after the snapshot was taken. If you take a snapshot and then never change a single file, that snapshot takes up almost 0 additional space.
You nailed it. It is just metadata. This is what makes it possible to have hundreds of snapshots without filling up your drive, as long as your rate of change isn't massive.
That is a huge paradigm shift for data safety. It means you can let an AI agent run scripts on your machine, and if everything goes sideways, you just tell the file system to point back to the map from 10 minutes ago. It is like a save point in a video game for your entire computer.
It really is. In the old days, if you broke your system, you were looking at a long night of reinstalling. With Btrfs or ZFS, it is a near-instant rollback.
Now, Daniel mentioned 3 big names: Btrfs, ZFS and XFS. Let us start with ZFS, because you often hear it described as the gold standard. What makes ZFS so special?
ZFS stands for the Zettabyte File System. It was originally developed by Sun Microsystems to ensure data was never, ever corrupted. They introduced end-to-end checksumming.
Can you break down what checksumming actually does?
Think of it like a digital fingerprint for every piece of data. Every time ZFS writes a block, it calculates a mathematical signature and stores it. When you read that data back, ZFS recalculates the signature and compares it. If they don't match, ZFS knows the data has been corrupted, what we call bit rot.
And if it is a multi-disk system, ZFS can actually fix it, right?
Exactly. It says, wait, the fingerprint is bad on disk 1, but I have a redundant copy on disk 2. Let me check that. Fingerprint matches? Great, I will give the user the good data and automatically repair the corrupted block on disk 1.
That is incredible. But ZFS has a reputation for being a bit of a resource hog. People say you need a gigabyte of RAM for every terabyte of storage. Is that still true in 2026?
That is a persistent myth. That rule of thumb was always mainly about a feature called deduplication. For general use without dedupe enabled, ZFS has never strictly required a gigabyte of RAM per terabyte of storage, and most home users run it comfortably with more modest memory.
So dedup is the real culprit there.
Right. Deduplication can still be very memory hungry, so it is usually reserved for very specific workloads. There is ongoing work on improving deduplication performance, but it still makes sense for most home users to leave it off unless they really need it.
You mentioned another hurdle used to be rigidity. You couldn't easily add one disk at a time to expand your pool.
Exactly.
Used to be? Did that change?
It did. RAIDZ expansion is now an official feature in OpenZFS. You can add a single disk to an existing array and the system will redistribute the data. Although it is still relatively new and, for very critical systems, people may want to test it carefully before relying on it in production.
Which brings us to Btrfs or Btrfs. This is what Daniel is using. Why would someone choose this over the mighty ZFS?
Flexibility. Btrfs is part of the mainline Linux kernel, so you can use it on most modern distributions without extra patches. It allows you to do things that would make a ZFS administrator sweat. You can have a pool of disks with completely different sizes, a 500 gigabyte SSD, and a 4 terabyte hard drive, and Btrfs can pool them together and, once you add a drive and run a balance, redistribute data across them.
And you can add or remove disks on the fly, right?
Yes. You plug in a new drive, tell Btrfs to add it, and run a balance command to reshuffle data. It also handles RAID differently. Btrfs RAID. One doesn't mean every disk is a mirror, it just means there are always at least 2 copies of every piece of data somewhere in the pool. It is much more intelligent about using available space, though the exact capacity and redundancy depend on the RAID profile you choose.
So if ZFS is the enterprise-grade vault, Btrfs is more like a high-tech modular shelving system. What about the third one, XFS? Is it even in the same category?
XFS is the heavy-duty truck. It is not a copy-on-write file system by default, so it doesn't have native integrated snapshots like the other two. Its claim to fame is raw performance with massive files and high concurrency workloads. If you are a movie studio handling 8K video files, XFS is often the fastest choice.
But Daniel asked about snapshots. Can XFS do that?
Sort of. XFS added a feature called reflinks. It allows you to make a copy of a file that shares the same data blocks until one is modified. You can use tools to create pseudo-snapshots this way, but it doesn't have the built-in self-healing or the integrated volume management of ZFS or Btrfs.
So to summarize, XFS for raw speed and massive files, ZFS for ultimate data integrity and professional-grade storage, and Btrfs for the enthusiast who wants flexibility.
Spot on. I would add that XFS has long been the default for Red Hat Enterprise Linux installations because it is rock solid at scale. Btrfs is much more mature overall now in 2026, but for a long time people were scared of its RAID 5 and 6 implementations because of the write hole, and current guidance still warns about using those modes.
Oh, right. Is that still a thing?
The advice is still to use RAID 1 or RAID 10 on Btrfs for maximum stability. If you want RAID 5 or 6 parity, ZFS is still the safer bet because of how it handles its RAIDZ structure.
Daniel mentioned he has an NVMe and an SSD in his pool. He was worried the slowest drive would dictate the speed. Is he right?
In a simple array, yes. But Btrfs is smart. You can tell it to store metadata on the fast NVMe and bulk data on the slower SSD. He is not necessarily wasting that speed if he configures it correctly.
This really changes the way you think about hardware. Instead of buying one massive drive, you just keep adding whatever is on sale to the pile.
It is a very democratic way of handling storage. It is essentially what ZFS and Btrfs bring to your desktop, the intelligence of a data center in your living room.
I want to go back to the snapshots. Should we be snapshotting before every software update?
Absolutely. Many distributions like Fedora and OpenSUSE do this automatically now. If an update breaks your drivers, you just reboot, select the previous snapshot from the boot menu, and you are back in action. It is an undo button for your entire operating system.
This is where the distinction between a snapshot and a backup becomes really important. Daniel said he should probably call it a snapshot and not a backup. Why?
This is the golden rule. A snapshot is not a backup. A snapshot lives on the same physical disks. If your power supply fries all 5 of your hard drives, your snapshots die with them. A backup must be on a different device, preferably in a different building.
Right. A snapshot protects you against software errors. A backup protects you against hardware disasters.
Exactly. However, these systems make backups easier. They have a feature called send and receive. Since the file system knows exactly which blocks changed, it can send just those specific blocks over the network. You can back up a multi-terabyte pool in seconds if only a few megabytes changed.
That is a game changer. So, for Daniel, with his 5-disk array and his penchant for tinkering, Btrfs was a great choice.
I think so, but he should definitely run a scrub occasionally.
A scrub? What does that mean for a file system?
It tells the file system to check every single block of data, calculate its checksum, and verify it matches the fingerprint. It is a way of proactively catching bit rot. On a 5-disk array, doing that about once a month is a common recommendation.
It is amazing how much work these systems are doing under the hood. We just see a folder, but underneath there is this dance of pointers and checksums.
It is one of the great unsung triumphs of computer science. We can store massive amounts of info and actually trust it won't vanish.
So, for our listeners who want to try this, what is the first step?
You can start with just one drive. Both Btrfs and ZFS work on a single disk. You won't get self-healing, but you get checksumming and instant snapshots. Just make sure you have a real backup before you start playing with your partitions.
That is a very fair point. I think we have covered a lot of ground here. We have looked at the magic of copy on write, the enterprise power of ZFS, and why XFS is still the king of speed for big data.
It is a fascinating world. And as storage gets cheaper, these systems are only going to become more common.
I hope so. I would love an undo button on my laptop for those times I accidentally delete a whole folder of photos.
Well, if you use Btrfs, you already have one. You just need to learn how to press it.
On that note, I think it is time to wrap up. Daniel, thanks for the prompt. It is always fun to look at the gear in our own house and realize just how much science is packed into those blinking boxes.
Absolutely. And hey, if you are listening and you have your own weird prompts, we would love to hear from you. Find us at myweirdprompts.com.
And if you have been enjoying the show, please leave a quick review on your podcast app. It genuinely helps other people find us. We have been doing this for over 200 episodes now, and it is your support that keeps us curious.
Yeah, a rating makes a huge difference. So thank you to everyone who has already left one.
We will be back next week with another prompt. Until then, keep questioning, keep tinkering, and maybe take a snapshot of your system, just in case.
Good advice. This has been My Weird Prompts. I am Herman Poppleberry.
And I am Corn. We will talk to you soon.
Bye for now.
So, Herman, be honest. If you were building a rig today, would you go Btrfs or ZFS?
Oh man, for my home server, I am a ZFS guy. I like that enterprise heritage. But for my laptop, Btrfs all the way? The flexibility is just too good.
Fair enough. I think I will stick to my simple setup for now. But I might just ask Daniel to show me those snapshots.
Just don't let him talk you into buying 5 more hard drives. Our electricity bill is high enough.
Good point. See you, everyone.
Sure.
One last thing for the tech-savvy folks. If you are interested in the deeper mechanics, look up the difference between a Merkle tree and a standard B tree. That is the real secret sauce behind how ZFS handles its data integrity at scale. It is a fascinating rabbit hole.
Oh, now you are really getting into the weeds. Merkle trees? That is some high-level stuff. But you are right, it is beautiful math.
It really is. All right, truly signing off now. Thanks for listening to my weird prompts. You can find all our past episodes on Spotify and at our website, myweirdprompts.com.
Hoi!
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.